Alright, so we will start the class. Do you guys remember what did we learn in the previous class? Does anybody remember what we learned day before yesterday? Yes, Aditi.
Tables and geometry.
Okay. Aniket. Aniket, can you hear me okay? Okay, in the last class, a lot of things did not make sense to Aniket. Is that correct, Aniket? Or things were making sense after some time? Okay. Okay. Hello, Hello, Naita. Okay. So, a request to everybody would be, you guys will stay on mute. When you have to talk, you will unmute yourself, talk, and then go on mute. Who is Jaya Info? I'm sorry? Keep your video on so that I don't have to keep on guessing. Lorians. Is this Rudraksh? Jaya Info is Rudraksh, right? Okay, yeah, this is better. So request everybody to keep your videos on. Now, what I was asking was, do you guys remember what we learned in the last class? Aditi said we learned tables and some things. Yeah, Niket, tell me, what did we learn?
We learned the tables and the geometry.
Geometry. Don't press your mouth and then speak. I can understand. Rudraksh, you will stay on mute. Rudraksh, you will stay on mute. Everybody stays on mute when you are not talking. Okay. All right. Rudraksh, you are in two places. Disconnect from one place so that it doesn't create some background noise. Okay. So we have. Okay. Let's do a quick roll call and we'll get started. Okay. Come on. So, Rudraksh, you have to be on. Disconnect from one place. You are in two places. Okay. I don't want to double count you. Okay. This is better. So we have Aditi, we have Anahita, we have Aniket, Asher, Rayans, Rudraksh, Samanvita and Sriyanvi. And everybody go on mute, including you, Rudraksh. Okay. Now, what I was saying was that whatever we learned in the previous class, that was a class in lieu of the Saturday class. So that is why we did tables first and then we started talking about geometry. So when we are talking about geometry, geometry is a vast subject. We can learn a lot of things about geometry, learning about shapes, properties, and then we learn about how do you calculate area and perimeter. We have not started talking about area and perimeter yet because we are trying to make sure that we understand the shapes very well. Where is Mishika? Aniket, where is Mishika? She's missing.
She's not coming to the math class right now.
Okay. She's not coming to math class?
Yeah.
Okay. We'll see. Alright. So let's get started. So we talked about triangles and its properties. Then we started talking about quadrilaterals. Quadrilaterals, as we speak, is a shape with four sides. And that is where we talked about rectangle, we talked about square, and we talked about parallelogram. Everybody remembers what we talked about? What are the properties? Can somebody tell me real quick how do you describe a parallelogram? Let's see who all remembers. Okay, Aditi remembers. So everybody else, don't wait for only Aditi to say. Okay, everybody else who remembers, raise your hand. I'll come to you guys one by one. Okay, Aditi, tell me two properties of parallelogram.
A parallelogram has two sets of parallel sides and is considered a quadrilateral.
Okay. Yes, Shanvi, tell me, what is your definition of a parallelogram? Shanvi, unmute yourself and tell me.
I was going to say the same thing.
Same thing? Oh no. Somebody grabbed your idea. It's okay. So yeah, as Aditi and Shanvi explained, a parallelogram is a quadrilateral. We are right now talking about all the shapes which are quadrilateral, so we don't have to say it again. But a parallelogram is a closed shape with four sides, and it has opposite two pair of parallel lines, or the opposite lines are parallel to each other. Yeah, opposite sides are parallel to each other. Is that a fair understanding? Now we are going to talk about three more shapes today. One is called, this is Samanvita's favorite shape, right? Samanvita, what is it called?
A rhombus.
Rhombus or a diamond. And everybody can see the board clearly, right? Okay. So, it's a shape called rhombus. Just give me 1 second, I'll be back. I turned off the light so that we can kill the reflection, okay? Now it's better? There's no reflection, right? Okay. So, this is the next shape that we are going to talk about, which is called rhombus. And this shape is called something. And this shape is called something. Let's understand all these three shapes, which will complete our understanding of what is called, or all the things that are classified as quadrilaterals. So everybody keep your videos on. Nobody has the option of turning off the video, okay? So here, this is, okay, let's start from here. This is called rhombus. Now, can somebody describe what is a rhombus? What are the things that you know about rhombus? Apart from saying it's a quadrilateral, nobody will say it's a quadrilateral. Everybody knows. Everything is quadrilateral. Yes, Naita, go ahead, beta.
It's a parallelogram.
Maybe, may not be. Okay, yeah, maybe. You're right. That is one example. Okay, we'll come to that. That is one property. Anybody else? Samanvita, you want to add something about your favorite shape?
No.
No? Aniket, do you want to say something about the rhombus or the diamond? What do we use the diamond for? It's a jewelry. It's used for jewelry, right? Yes, Asher.
Yeah. It's a rhombus.
No, rhombus. It's a rhombus. I'm saying, what are the properties that you remember? Or what are the things that you know about a rhombus? Okay. Everybody is speechless. So I heard only one thing, that is, it's a parallelogram. Yeah, it is a parallelogram because in case of rhombus also, the opposite sides are parallel. Now, when you want to visualize what is a rhombus, if you want to think about is, it's like a square. Let's say, let me make it look like a square. Let's say this is a square. Okay, let's say this is a square. If I squeeze it from two corners, what happens? It becomes thinner and longer, correct? That is how it becomes a rhombus. Meaning, if you imagine this square, this was my square. What I did was, I squeezed it from two corners. What happened was, when I squeezed it, it became thinner and longer. So what that means is that the length of the side did not change. They just got closer. Meaning it was the angle, like, let's say if you visualize two of the sides of a square, it was at 90 degree. Somebody squeezed it. The angle became smaller here. The angle became smaller here. But the length of the side, see, if these two hands, my two hands were the sides of a square, when somebody squeezing it, my hands are not becoming smaller, right? It's remaining the same length. So the sides are remaining the same, but the angle between the sides became different from 90 degree. Yeah. So one property of a rhombus is all the four sides are same because this is a squeezed version of a square. Does that make sense? Yeah. Who joined in between? I see Sanvi has joined. Hello Sanvi. Good morning. It's a morning for Sanvi, right? Yeah. Okay. So Sanvi, we just started talking about geometry. So right now we're talking about the properties of different shapes. So we have talked about triangles in the previous class, which you were not there. Then we started talking about quadrilaterals, and that is where we started with square, rectangle, and then parallelogram. Right now we're talking about rhombus. Okay. So our goal is to make sure that we all understand very well about the shapes. We know about their properties, right? If I say that Sanvi is a child who has hair of my size, that's not the right property of Sanvi, right? Sanvi will say, no. You might have small hair, I don't. Correct? So that is how we are trying to make sure that we understand each and every property of the shape very well. Because if we understand the property, then it becomes easy to deal with them. Right, Aniket? If I assume that Aniket is an 18-year-old boy, I will ask him to drive a car. He will say, no, I don't have a driving license. That is not my property. Correct? So likewise, every shape that we will deal with, we need to be very clear about the properties of it. That's what we are doing right now. So coming back to the point, a rhombus is nothing but a squeezed version of a square. If you take a square and squeeze it from two corners, then you get a rhombus. And what that means is, all four sides have same length. Only thing happened was the sides came closer. The angle became smaller. So the angles, all the angles are not 90 degree. Angles are not 90 degree. So if you want to differentiate between a square and a rhombus, your biggest difference is square has all angles as 90 degree, rhombus don't. Yeah? Does that make sense? If ever anybody, I'm sorry, Vita?
Yes, sir.
Okay. So keep that in mind. If somebody says, describe the difference between a square and a rhombus in one line, you will say that a square has all angles as 90 degree. Rhombus don't have all angles as 90 degree. Wherein every other property matches. Make sense? Okay. Now, so we learned, okay, if I'm talking about rhombus, all the four sides are of same length. This angle looks to be bigger than 90 degree, and this angle looks smaller than 90 degree. And that's okay. I mean, we don't really have to go deeper into it. As long as you know that all the angles are not 90 degree, you're fine. Yeah? And then what Anahita said, that they are also parallelogram, because when you are squeezing it, you are squeezing that in a very controlled way. You're not breaking it like this. You're applying the force gently, and it's changing its shape in a very controlled way. That is how the sides, even if they are coming closer, but then you will see that these two sides remain parallel and these two sides remain parallel. Okay? So that's why it is a parallelogram also. Because parallelogram says any quadrilateral where the opposite sides are equal and parallel, they are parallelogram. Here what do you see? This side and this side are equal and they are parallel. This side and this side are equal and parallel. So yeah, it's a parallelogram as well. Everybody clear?
Yes, sir.
Okay, let's move on to the next shape. Now we go to kite. Okay, before I move on, there's one more thing that you will come across when we will learn more details about the rhombus is if it's a rhombus. It's a rhombus. Here, what you know that okay, all the four sides are same length and the angles are not 90 degree. And it's a parallelogram also. This side parallel. This side parallel. Now, this is another thing that comes into play in case of a rhombus, and that is called diagonal. Meaning, when you join the opposite corners of the rhombus, these line segments joining the opposite corners are called diagonals of a rhombus. Aniket, is that okay? We are just calling it a name by name, diagonals, because they are diagonally opposite to each other. Okay, like I am known as Biren, you are known as Aniket, Anahita is known as Anahita, Aditi is known as Aditi, Rudraksh is known as Rudraksh. These sides are known as diagonals. And why diagonals? Because they are the opposite vertices of a rhombus. When you join them, they are called diagonals. Now, we don't want to know what it is called. We all know it. But the important thing that we need to be aware of is when you join the opposite corners, they meet each other at 90 degree. The diagonals meet each other at 90 degree. They are perpendicular. Meaning, if you randomly pick any rhombus, this is a rhombus, okay? You just join the opposite thing and you will know that okay, this is 90 degree, this is 90 degree, this is 90 degree, this is 90 degree. They meet at 90 degree. Now, if you look at, let's say this is also quadrilateral, right? If you join these two, do you see they are all meeting at 90 degree? No, they don't. Yeah? So that's a unique property of a rhombus. When you join the opposite corners of a rhombus, the line that connects the opposite corners, that meets at 90 degree. Is that okay? Okay, let's move on. There is one more thing that I want to talk about. I will not talk about it because I don't want you guys to get loaded with a lot of information and then say that what this guy is doing with us. So let's look at the next shape. It is called kite. Tell me who all has seen an actual kite? Yes, Ashar. Yeah, sure, go ahead. You had raised your hand. Tell me, have you seen the kite before?
Yeah.
When? Where? What it does? What it is used for?
It's used for like flying and flies in the air.
Mm-hmm. Okay. Yeah, Niket, when did you see a kite? Tell me.
I thought I did, but actually I didn't.
Okay. And Rudraksh, when did you come across a kite?
In India?
India. Did you fly a kite also?
Yeah.
Is it fun? Sanvi must be experiencing the kites right now. Yeah? Okay. How about you, Aditi?
I saw them at Lakeview Park in Makar Sankranti Festival.
Yes.
Where they do kite paddling and kite flying. My favorite part is kite paddling.
Alright. No, that's one of the events where kites are people fly kites. Yes, Anaita.
I've never seen a kite before.
I'm sorry, beta?
I've never seen an actual kite.
You have never seen a kite before. How about you, Rayans?
I've seen one thing. My friend has one.
You have, and you had the experience of flying a kite before?
No, not No, I actually didn't fly it.
Okay. Yes, Yanvi. When did you fly a kite? Tell me.
I've never really used a kite in India, but I used like a kite, like my friend has one.
Okay.
So I used that one.
Cool. So coming back, see, again, whatever we are learning here in the class, these are called life skills. We are not learning math to get 100%. That is not the goal. Our goal is to see how math is relevant to us, and that is what we are trying to see here. See, we talked about rectangle, square. The screen that you are using right now, it's a rectangle. So relatable, correct? The board that where I'm drawing is a rectangle. That is why we are trying to learn about these shapes. Yes, Anahita, you're saying something better?
Once I flew one of these plastic kites, does
Uh-huh.
that count?
Yeah, everything is, see, anything that you fly which looks something like this is a is a kite. Yes, Aniket, you're saying something? Or else stay on mute, better. Okay, so now we are talking about the shape called kite. And kite, when you look at little carefully, you will see that it is from the same quadrilateral family, meaning it has 4 sides, no denying that. But it is little bit unique. Let me make it more clear to you guys. A kite would look very different compared to the other shapes that we have seen so far. And what is the difference? The top 2 sides, these 2 are of same length. The bottom 2 sides are of same length. Okay? So when we looked at rectangle, we saw that opposite sides are of same length. Here opposite sides have no relationship. Opposite sides have no relationship. When we looked at a rhombus or a square, we saw all sides were same. Here all sides are not same. But what is the relationship among them? The top 2 sides are same length and the bottom 2 sides are same length. That is what is a kite. And whoever has had the opportunity of flying a kite, you would have seen that what you do is you put the strings in these 2 places and connect it with the larger string, and then you use it for flying. Okay? So anyways, we are not going to learn the techniques of flying a kite, because I'm not very good at it. Somebody used to fly it for me and then give me the control for this. That's what I used to do. But anyways, so coming back to the property of a kite, only thing that we need to know is the top 2 sides are of equal length, the bottom 2 sides are of equal length, and there's no other relationship. Nobody else, there's nothing talked about from an angle point of view. As you can see, this angle doesn't seem to be of having any relationship. These 2 angles might be same, but let's not worry about it for now. Only thing that you might want to think about is what happens when I join the opposite corners. Here you will see one more thing common to rhombus. That is when these 2 are called diagonals again. The opposite corners. Any shape that you pick up, if you join the opposite corners, these are called diagonals. Okay? And as you can see right now, I chose a rectangle and I joined the opposite corners. See, these angles don't seem to be 90 degree. These are not 90 degree, correct? Do they look like 90 degree to anybody? No, right? They are not. So, in case of a rhombus, we saw that the diagonals meet each other at 90 degree. In case of kite also, that is the thing. Here also, all the angles are 90 degree. Not the angles inside the rhombus, but the angles between the diagonals. Yes, Aniket. Yeah, Aniket, go ahead. Fire your question.
I didn't have a question.
Okay, that's fine. Now, if anybody has a question, don't hesitate, don't be shy. Nobody has to be shy with me, okay? Alright? Alright. So, moving on. So, we learned about rectangle, no question, no doubt. We learned about square, no question, no doubt. Be on mute, beta, okay? So that I don't hear the background noise. Yeah. Then we talked about rhombus, no question, no doubt. Then we talked about kite. I hope no question, no doubt. Now I have a question. Is kite a parallelogram? Let's see. What is your thought? Rudraj, tell me. Is kite a parallelogram? Okay, let's see what Riyan says. Yeah, Riyan, go ahead.
I think it is a parallelogram.
I'll come to you asking why. Okay, let's see what Anahita says.
I also think it's a parallelogram.
You also think it's a parallelogram? Okay. Anybody else? Yeah, Rudraj.
I also think it's a parallelogram.
You also think it's a parallelogram? Okay.
Yeah.
Let's see what Aditi says.
Parallelogram.
Parallelogram. Ashar.
Parallelogram.
Now you guys are giving me a chance to make everybody feel bad. It is not. Now, see, if you just recall, forget about the kite for now. What qualifies something to be called a parallelogram? When the opposite sides are parallel and equal. Naita. Yes.
It has to have at least two parallel sets of parallel points.
It has to have the opposite lines parallel and equal to each other.
At least two.
Not at least two. At least two is not right. I will tell you why when we talk about the next shape. Okay. So a parallelogram is a shape or a quadrilateral where you have opposite sides parallel and equal to each other. Now look at the opposite sides here. These two guys are same, but I never said these two are same. Okay? So they are not equal. So first criteria failed. Are they parallel? Maybe, may not be. I'm not sure. But my first condition itself has failed. For anything to be called a parallelogram, the opposite sides have to be equal and parallel, and we can clearly see that these two sides are not equal, these two sides are not equal. The opposite sides are not equal. So I will rule out the consideration for calling it a parallelogram in the first go itself, without even thinking whether it's parallel or not. Is that okay? No, and if you guys want to take some time to digest what I'm saying, that's okay. I'm just trying to be doubly sure that this is not only my understanding, it has to be our understanding as a group. Yeah? So many round faces with a surprise on the face. Oh, like that. Okay, don't play with emojis. I mean, I got everybody's feelings, okay? And there was no intent to hurt anybody's feeling. What I'm saying is, you don't have to trust me. And you don't have to trust anybody in particular. What we have to trust is the knowledge and the information that we are collecting about each and every property. And trust me, this is the building block for us. When we are talking about the shapes of the properties of the shapes, that is when we are making ourselves ready to digest or understand a particular shape, and we are in that phase right now. So we should not have any doubt. Okay, is rhombus a square? No, it's not. That's the most important difference. Rhombus and square have something in common. They both have equal sides, but they are not square because there's a difference, and that difference says that squares will have all angles 90 degrees, rhombus will not. Ruled out. Correct? So that conviction, that confidence is what we have to have when we talk about any shape. And that is what will help us dig deeper into it. Okay? We will even look at what is the area of different shapes. Okay? Yeah? Not right now. Let's first understand the shapes. Is that okay? Nobody has any grudges with me so far, right? Nobody is upset with me? No? What happened, Aniket? You're hiding your face because you don't like my face? I like your face, so you have to show it to me. Keep your video on. Yeah? I like All kids, okay? I have special affinity for kids, okay? I love kids, okay? So I love seeing you guys, okay? Okay, all right. Yes, Aniket.
It was an accident. I accidentally pressed it.
No worries. I love those cute accidents at times. All right. So now we know about the property of a kite. We are saying that kite is a quadrilateral where the top two sides are of same length, the bottom two sides are of same length, and the diagonals meet each other at 90 degree. And it is not a parallelogram. Okay? Everybody with me?
Yes, sir.
Okay.
Yes, I'm with
Let's move on.
you. Sir.
Now I'm going to the next shape, and that is where I will answer Anahita's question. Right? Anahita was not happy with me. She said, "Sir, you are teaching me something wrong. You are saying that a parallelogram should have at least one pair of parallel lines." And I'm saying no. Why? Because there's one more shape in the quadrilateral family that you all guys know. And what is that called?
Trapezoid.
Trapezoid or trapezium. Yes, Aditi.
It's called a trapezoid.
Trapezoid or trapezium. I mean, whatever. Yeah, Rahita.
I said a shape needs to have at least two parallel sides.
Okay. No, that's okay, beta. See, I'm not trying to prove anybody right or wrong. What I'm saying is we are trying to reconfirm our understanding. There could be times when I will go wrong, where you guys will teach me saying, okay, no sir, you're not supposed to say this. This is how it is. And you just have to put a little bit of extra effort to convince me. Because unless I am convinced, I will not agree, right? So you'll have to give me information to be convinced. Yes, Yanvi.
Wait.
Weight 75 kilos.
Is there a thing called a isosceles trapezoid?
Nope. There is nothing called isosceles trapezoid. Isosceles is a property of triangles only. And does everybody remember what is the property of an isosceles triangle?
Yes, I do.
Go ahead, tell me. Tell everybody. Let's make sure. Yeah.
One side, two sides are not equal, and one side is. One side is unequal, and two sides are.
Right. Everybody agrees to what Rudrak said? Okay, let's move on. So this shape is called trapezoid. And the property of a trapezoid that we need to know is that a trapezoid is a quadrilateral, because we are still dealing with the quadrilateral family, where only one pair of lines are parallel to each other. Only one pair. Meaning this line and this line are parallel. That is why that is the only property of a trapezoid that we need to know. Meaning, if you have a quadrilateral where only one pair of lines are parallel, and this line and this line are not parallel, then only it will be called trapezoid. Because by any means, if this line also becomes parallel to this guy, this turns out to be a parallelogram. Okay? Parallelogram says the opposite sides are parallel and equal. So if these two sides are parallel and these two sides are parallel, then only it will become a parallelogram. Because when you have both the sides parallel, the sides will be equal as well. Let's not worry about it for now. We'll prove it later. But what I'm saying is, when you have only one pair of lines being parallel to each other, that's the only situation when you'll call a trapezoid, when you will call this shape as a trapezoid. Now if I ask a counter question saying, is trapezoid a parallelogram? What will be the response? Nope, thumbs down. Boo, whatever you call it. Yeah. So a trapezoid is not a parallelogram, as simple as that. Because for something to be called a parallelogram, it has to have each pair of opposite lines being parallel and equal to each other. Just because we saw that a trapezoid mandates us to have only one pair of lines being parallel to each other, then only it's a trapezoid. Now, what that means, is this line and this line equal to each other? Are these lines and these lines equal to each other? Line or line segment, whatever we call it. Do they look equal to each other, the opposite ones? Any guesses? Think about it. Yes, they look equal. I know my drawing skills are not great. What I'm trying to learn from you guys is, if this thing looks like a trapezoid, if this is a trapezoid, is there anything that is equal here? Yeah, Rudraj, go ahead.
It was an accident. They wanted me to do that.
Another cute accident. So many cute accidents. Okay. Aniket, any thoughts, beta? Do the opposite sides look equal to each other? They look equal? Are you sure?
No, but they are parallel lines.
No, my question is not about parallel. We agreed that these two lines are parallel to each other. They are not equal. That's a judgment I wanted to hear from you guys. Is there anybody in the class, apart from Aniket, who thinks that these two lines are equal or could be equal? No? Yeah. Anaita, you want to say something, beta?
I think they're equal.
They're equal? Okay, that's one opinion. Let's see, anybody else? Rudrak saying not equal. Aniket said not equal. Aditi, what about you? Shyanvi?
I think they're not equal.
They are not equal. Okay. Sanvi? Does it look equal? Do these line segments look equal to each other?
No, because one is shorter and one is bigger, so obviously it's not.
Louder, but I could not hear you.
No, because one line is shorter and one line is longer, so it's not.
Okay. So I'll come back to Anaita again. So Anaita, you just discount my drawing skills, okay? My drawing skills are not great. But as far as this shape is concerned, this line and this line are of different length. They are not of equal length. They are parallel though. Okay? They are parallel.
I thought you were talking about the line on the left and the line on the right.
Maybe, may not be. See.
I thought you were talking about that.
Okay. So, okay, I'll come back to that. But for now, these two sides, the parallel sides are not equal for sure. Everybody agrees. Now, this is a trapezoid where it's making you believe that this side and this side are same length. Okay, how about this now? Are they equal now? No. Are they still a trapezoid? Is it still a trapezoid? Yes, it is. Because trapezoid is a very simple shape which has no high expectation. It says that you can call me a trapezoid if one pair of lines are parallel to each other. So these two are parallel still. They're still parallel. No matter how far you extend them, they are not going to meet. The distance between them is going to remain the same. So they are still parallel. As long as you have one pair of lines parallel to each other, it's a trapezoid. So now look at the length of this side and this side. They are not same. So what I'm trying to emphasize here is that a trapezoid only asks us to guarantee one thing, that is only one pair of lines are parallel to each other and none of the sides are promised to be of same length. Okay? Is that okay? So we learned about all the possible shapes within the quadrilateral family. Anybody in the group has any doubt about these things? And it's okay to have doubt. It's perfectly fine to have doubt. I mean, When I
No.
was, okay, no doubt, that means one thing. And you guys are much more intelligent than me when I was your age. And take that as a feedback that you guys are more intelligent than me. At least when I was your age. Okay? And that's a very good sign because no. If you guys are more intelligent, then it'll be easy for me to make you guys understand. Alright? Coming back to, and I'm not joking, okay? I'm being very serious about it. You guys are much more intelligent than me. I was not. Okay? So we talked about all the shapes in the quadrilateral family. Let's go. So we talked about one, line, segment and ray. We talked about two when it makes angles. That is when we talked about acute angle, right angle and obtuse angle. We went from 2 to 3. That is when we talked about triangles, where we looked at two varieties or two categories, one based on sides, one based on angles. When we looked at sides, we talked about equilateral triangle, isosceles triangle and scalene triangle. When we looked at angles, we talked about acute angle triangle, right angle triangle and obtuse angle triangle. Correct? And again, some of you had asked this question, so I'm repeating it one more time. Is there something called straight angle triangle? No. There is nothing called straight angle triangle, because what is a straight angle? Straight angle means when two line segments make 180 degree. Meaning it becomes a straight line. If you have to make a triangle, if these two angles are 180 degree already, the third point, then this side is not considered at all. This becomes one side, right? So there is nothing called straight angle triangle. See, when you're talking about a triangle, you're talking about three angles. If this becomes straight angle, expands, then you have one line and you're plotting another line on the top of that. Doesn't look like a triangle by any means. Yeah? Or there's another mathematical way of thinking about it. That says sum of all the angles is in a triangle is 180 degree. Okay? Sum of all the angles in a triangle is 180 degree. If one of your angle is already 180 degree, other two angles are adding up to become 0 degree. What kind of angle we are talking about? 0 degree means what? One line, other line on the top of that. That is when it is 0 degree. You'll not be able to see a triangle actually. That's what I'm trying to say. Yeah? Let's not break our head on this one for now. Only thing that you have to remember is there is nothing called a straight angle triangle, because if one angle becomes 180 degree, there is no space or value left for other two angles. Yeah? Make sense? So we looked at triangles. Then we talked about from 1 to 3, we went to 4. And that is when we started talking about the quadrilateral family. We just concluded, where we talked about rectangle, square, rhombus, kite, trapezoid and parallelogram. And I'm assuming that you guys are very clear about these shapes. Like if you guys join a class, you will not assume that Aniket is going to teach. Aniket might teach when he grows up, but in this class he will not. He is a student. You all know his property, that Aniket is a small boy, wears glasses, and he's going to 3rd grade. So he's not going to be a teacher. Since you know his property, he's not going to teach. Likewise, when you know the property of the shapes, you would know what you can do with what shape. Okay, so I'm assuming that everybody is clear about all the shapes so far. Now, after 4, what comes? 5. What is that called? A hut or a pentagon. 5 sides make a pentagon. If you have other shape which has 6 sides, what is that called? Hexagon. If you have a shape which has 7 sides. What is that called? Heptagon. Okay, but do we have to worry about it? No, we don't. One second. So, all these shapes, these 1, 2, 3, 4, these are called basic shapes. Triangle, quadrilateral, these are called basic shapes. Because 1 and 2, line segment is not called a shape, that's just a line. Angle is not called a shape, it's just an angle. Because it doesn't close, right? It remains open. So things that get closed, that is what is called a shape. So these are the basic shapes. When somebody talks about basic shapes, we are talking about essentially about triangle and a quadrilateral. Now, these are called compound shapes or combined shapes. You'll ask me why. So let's look at it. If I'm talking about, let's say after 4 I went to 5, and that is called pentagon. So pentagon is a shape which has 5 sides. I'm saying that it's a compound shape or a combined shape. Why? Because it is made of 2 simple shapes. If you join these 2 corners, what do you see? There's a triangle here and there's a rectangle here. So there are 2 simple shapes that is getting combined to make a pentagon. That's why it's called compound shape or combined shape. Does it make sense? And I'll tell you why we need to talk about it. If somebody says that, okay, find out the area of a pentagon. Okay. I'm already 49, next year I'll turn 50. I have no formula that I've learned for finding out the area of a pentagon. And I don't think I can learn about it in my lifetime because there is no formula that exists. Okay? Why? Because there is no need. But we still have to find out the area of the shape by breaking it into pieces. Because we know it's a compound shape by joining the 2 corners. Now I have a triangle and a rectangle. If I know the area of this triangle, if I can find out the area of this rectangle, I can join them together. That becomes my area for pentagon. So why to waste our energy to learn a new formula which is not needed? Make sense? Yeah?
Yes, sir.
And we have a lot more options. I can say, okay, fine. I can break this pentagon into a triangle and a rectangle. Or if I love triangles, I mean, I don't love any particular shape as such, but I'm saying, in case I have special affinity for triangles, I'll say, fine, I can break this pentagon into 3 triangles. 1 triangle, 2 triangle, and 3 triangles. And add the area of this triangle, this triangle, and this triangle. That becomes my total area of the pentagon. Yeah? So these are called combined shapes or compound shapes. Okay? That's why we don't bother about learning the formula for these shapes. Okay? And when we talk about the area and perimeter stuff in the coming classes, that is when you will appreciate what I'm talking about right now. Yeah? Everybody clear?
Yes, sir.
Similarly, what comes after 5? Is it already time? No, we have 10 more minutes. What comes after 5? Yes, Rayans. 6. Yep, everybody agrees. That was a very stupid question, I know. But I was just trying to make sure that, like, somebody has woken up Sanvi, everybody is awake with me, because sometimes when I'm teaching in a very bad way, kids will start falling asleep. And I'm just trying to make sure everybody is awake. Yep, see Anahita dozed off just now. Yep, okay, don't do that, beta. It's okay, wake up. Okay, now, after 5 comes 6, and that is a shape which has 6 sides. It's called hexagon. Hexagon. Again, do you think by the time I turn 70, will I know the formula for finding the area of a hexagon? No. If I could not learn it till 49, there's no hope left. Okay? Whatever opportunity I had to learn, that is exhausted. I cannot learn anything new now. But then, I have a way to solve this problem. Sriyanvi, can you tell me how will I find the area of this shape if I don't know the formula for this guy?
To find the area, you would, I think you might do 1 times width, or
I will break it. Simple answer to that is break it into simple shapes that you know about. Okay? And my simple shapes are up to here. So I will break this guy into simpler shapes. And my only way to do that is by joining the corners. See, now when I join the corners, what do I get? I get one triangle, another triangle, and a rectangle. Yeah? And if I find the area of this guy, area of this guy, and area of this guy, I can add them together. That becomes my area for the entire shape. Yeah? Sammy, you are 7 minutes early for your class.
yeah, I just stayed here, sir.
Yeah, you can still say hello to your old friends. Alright. So, what I'm saying is, this is a hexagon, and unfortunately your teacher was never serious about his studies. So he could never learn how to find the area of a hexagon. There is no formula that your teacher tried learning. And I'm spreading the bad things among you guys as well. I'm saying you don't have to learn this, because you already have a solution for this. Guys, stop playing with emojis. Don't get emotional about each and every sentence of mine. Alright, so coming back to this one, what I'm saying is you don't really have to. Whatever I said, there was an intent. Yes, Ashar.
Can I repeat it?
Yes, please. So, because for hexagon, I don't really have to burn my midnight oil to learn the formula for this guy. I have an easy way. I can just break it into pieces. And that's what I keep saying in every math class. Saying, okay, if you're talking about math, math is a subject that gives you the opportunity to break it into smaller pieces. Not like breaking your arm like what Rudraj did. But break the problem into smaller pieces and then you can deal with it. So here, this hexagon, I can break into smaller pieces. I got one triangle, one rectangle, and one triangle. And again, it is my choice. See, if I have spatial affection for triangles only and I hate rectangles, if I ever say that I hate rectangles, I can still live with it, because I will only make triangles out of it. I will join the corners in such a way that I only get triangles. I got one triangle, two triangle, three triangle, four triangle. So it's always up to us how we want to break it down, or depending on what information we have, to break it based on our convenience. Make sense, Riyaz? Yeah? Sanvi, with me, beta?
Yes.
Yeah? Yeah, Nahita?
What if we don't like triangles and we only like squares? Can we break it into only squares?
Okay, so that is where you'll have to choose among the best options you have. Let's say you like only squares and this guy is not giving you the opportunity. Then you have to expand your choices a little bit more. What I'm saying is, if you have three choices to make from and you like two of them, then you can choose those two. And if you don't like any of the option that is given to you, then the only option is making that question go wrong, which is something that we'll not like. What I'm saying is, again, my statement had a different purpose. The purpose was that you can break it based on your convenience. What I mean by that is, let's say if you're trying to find out the area of this triangle, and there are certain things that you need to know, but somehow that information is not given to you. You have some other information. So in that case, it's okay, fine, I'll not break this like a triangle, but probably if I join these two corners, it becomes a trapezoid, or let's say a rhombus. I'll probably use that area and then these two areas. So basically it's not only based on the choice or the things that you like, it might be based on the information you have that you can use to derive what you want to derive. Yeah? Yeah. So again, here my point is that we are all very focused about what we are trying to solve based on what information we have, and we'll keep that as a consideration for breaking it to solve it based on our convenience. Okay? Is that okay? So what are the things that we learned today? I'm doing a quick recap. We talked about the remaining three varieties of a quadrilateral, where we talked about rhombus, kite and trapezoid, and we clicked on each and every property, and we should not have any doubt about the difference between the properties. Usher. Okay, so see, this is evening time when I start feeling hungry, and if you show me pizza, I might end up biting my screen, right, which I don't want to do. Okay, so we talked about the three variants of quadrilateral, which is kite, rhombus and trapezoid, and the properties. Then we talked about what are the things that comes beyond that, which is not a simple shape, and we kept on increasing number from 5 to 6, 6 to 7, 7 to 8, and we can just go on. But what I'm saying here is that you don't have to worry about knowing the formula of these shapes which are bigger than 4 sides, or which has more than 4 sides, because you can always break it down into simpler shapes and use that understanding for deriving the properties or other things about it. Okay? With that being said, I will let you guys go, take some rest, and be happy about the fact that there are no classes this weekend, only this weekend and next weekend. But we'll meet again on coming Tuesday. Alright? Happy? Have fun. Alright. Yep. Bye-bye. Bye-bye. Bye-bye.